Let's say we had data about the length of time it took to complete an exam. What would the level be for that data? If you look at the book on page 7, it has a chart for the levels of measurement, and this would be the ratio level of measurement. The data can be arranged in order. Yes, you could take all the different lengths of time it took for students and you can place them in order from the whoever finished first to whoever took the longest. In addition, the differences between data values and ratios of data values are meaningful. Yeah, think about the differences between data values. If I took 30 minutes and you took 40 minutes, you could say I finished 10 minutes faster. That has meaning. And ratio, if I took 1 hour and you took 2 hours, you could say I took half as long as you. That has meaning. And there also is a true zero, which would be someone who finished the exam in 0 minutes. Definition for class limit is on page 41. A lot of people chose B, but B is the class width, and you can see that on page 41 as well. Correct answer was D for 11. Continuing to talk about classes and class widths. Once you know the class width, which again page 41, you can read on how to figure that out. All the classes should have the same class width. So some of the problems, like this one here, this first class, if you subtract those numbers, there's 24 difference between that first class. But then the next one's only 23 different. And then the next one is 25 different. So they have different class widths for the 3 classes. That's a no-no. That's how you know C is incorrect. And then B would be a correct for this one. The class widths are correct because they're all the same here. 24 difference, 24 difference, 24 difference. There were a lot of problems that involved dog sled teams. I got sick of hearing about dog sled teams, but you really needed to just type all these numbers into Excel. It could take 10 minutes or so, but then you can sort them, find the class size, and quickly make a histogram with a few clicks in Excel to answer the questions like 30 or like the previous ones. You could see what the correct graph should look like. Don't expect too many like this on the final. Since it is a timed exam, there wouldn't be time for you to type in a bunch of these like there were on the midterm. But the midterm, you did have all week to work on it, so it wasn't too much given that you had 7 days. A lot of people missed the question about whether a scatter diagram showed linear correlation or not. Look at page 139 for examples. You'll hardly ever see a scatter diagram where the line or the dots are perfectly lined up. That just doesn't happen. But if they're somewhat lined up, a line would kind of be close to most of them. It's linear correlation, and the closer it is to a line, the stronger it is. The more spread out they are, the less strong it is. But a diagram like this would have no linear correlation, where it's just completely all over the place. You can't draw a line any specific way that would best fit those points. Page 144 at the end of this section also has some good examples. This one would have some moderate linear correlation. A line would go this way through most of the points or along their path. This one has none because it keeps changing directions. They're not straight at all. And this one's very high linearly coordinated. These points are almost all in a straight line. Again, we have moderate, very high, and this one's none. Should I draw a line this way, this way, this way? You can't really tell because the dots are all over the place. So there's no correlation here, no correlation there. 38, there is a strong negative correlation between the number of infant deaths at birth and number of people over 65. A negative correlation. This means they're not moving in the same direction. The infant deaths at birth have been going down. There's been less of those. The people over 65 have been going up. There's more of those. What could cause that? And that's better healthcare and treatments is going to have less births and then more people over 65. And that's a negative correlation, means they're moving in opposite directions. For doing probability assignments, look at page 176. There's 3 ways you can come up with the probability of something. There was a problem on the test about the probability, a prediction about a sports team and how many games they would win. Sports probabilities are all off intuition. You look at both teams and you see the players and how well they gel as a team, their skill level, their strength, their athleticism, and you just make a judgment call about the likelihood of one team winning or not. Relative frequency wouldn't work with sports. That'd be kind of silly. If you looked at the Pacers versus the Bulls, the last 10 games, that'd be a sample. And you say the Pacers won 4 of the last 10. So then you look at the next game, would you say they have a 40% chance of winning just because of their 4 of the last 10? You wouldn't do that because it's a different team now than it was for the previous matchups. So this new game coming up is different than the last 10. You wouldn't look at the last 10 to try to pick who's going to win this one. You'd look at the current teams now and use your intuition. And sports don't have equally likely outcomes. The teams are both different, made up of different players. So again, this one would not work for sports either. Intuition is how you make probability assignments in sporting events like basketball or football. Page 198, there's a summary of basic probability rules. These are all good to know. There's 8 of them listed there. One of the most commonly missed problems on the test was about people having good ideas, and it asks what's the probability that you have a good idea. I think it was in the morning and in the evening, or between midnight and 6 or something. But it was an and. It was the probability that you have a good idea at this one time and you also have a good idea at the second time. And to do an and probability for any situation where you're trying to find that both events are going to occur, you're going to multiply here. The probability of the first event multiplied by the probability of the second event, and how that's altered because we know the first event has occurred. Now, if the events don't affect each other, like independent events, like ideas are independent, you can just multiply A times B because the after A occurs. That's what independent means. But in general, anytime you're doing an and, it's always going to be multiplication. Just want to point out 49 so you're ready to expect things like this on the final, or I guess to pay attention to the wording more on the final. Don't want you to be caught off guard or tricked by any of the questions. So it's about somebody who owns a computer store. He counts 130 people walk by. 58 people come in. Of the 58, it says 25 bought something, but then it asks you to estimate the probability that someone will buy nothing. So this number 25 isn't what we're going to use. Well, we kind of will. There's 58 people in the store and 25 bought something. So we really need to look at 33 people bought nothing. And that's what we're trying to figure out, the probability that someone buys nothing. So 33 out of 58 people is 0.57 when you round. So D.